get started. In 1969, the National Aeronautics and Space Administration program sent 3 men to the moon and then brought them back. And that was all done using handwritten math and computers the size of a sedan that cost hundreds of thousands of dollars. In 2015, Z&E Science reported that the average smartphone has about 1 million times more processing power than all the computers used during the 1969 space mission combined. So why does it feel like the technology is not really synced up, right? Like, shouldn't we be like living like the Jetsons by now? Well, the answer sadly is no. And the reason for that is something we call diminishing returns, which has to do with something called Moore's Law, which states that around every 2 years, roughly, computers get twice as much power and are twice as cheap. But we are starting to find out in this modern time that there's only so much space on a microchip that we can fit transistors, and there's only so much power we can put on these things. The other issue we have is that a majority of the resources we put into computers tends to be either for computational speed and for user convenience. To me, that just goes to show that it's not really about having some great technology or some good resources. It's more about having a good idea and implementing it. So I'm going to talk about 2 specific computational powers that are pretty relevant right now. They're pretty hot in the field, and that's going to be neural networks and cloud computation. So I'm going to take the time right now to talk about neural networks just by themselves. And neural networks are really just a learning system for your program to gather information, process that information, process it, and then learn from it. So, and it does this because it's based off the human brain. So the way the brain makes assumptions and has biases, it's kind of the foundation for neural networks. So if you were in a classroom, and it's an algebra classroom, and the teacher writes on the board X and an O, you might assume that maybe these are going to be variables you're going to be using. And let's say later on during the week, you're going to have a letter on Valentine's Day, and at the bottom it says X and O, and from that you're going to be like, well, those are probably hugs and kisses. And the reason you make this logical leap is because your brain's going to search for anything else in that experience. It's going to reference it, and it's going to be like, I'm pretty sure this is math. Math has variables. Therefore, this is probably going to be the variable we're going to be using. But no one's told you this information. You're just making kind of a logical leap. Neural networks work pretty similarly. You're just going to give the information, and it's going to try to classify and identify all this information and try to make sense of it. So let's say we wanted to make a program that can take a picture, and it'll take a picture of a handwritten piece of paper, and on that paper we're going to have a digit between 0 and 9. So we want it to be able to tell us what this digit is. So what we're going to do is we're going to have what's called nodes, and each of these nodes is going to have a number from 0 to 9 representing it. And basically it's going to be like a person with a buzzer. Whenever that node is activated and it sees a 4, and it says, well, I'm node 4, that looks like a 4, I'm going to buzz in. Your computer is going to learn from that. It's going to see what 4s look like, and you're going to give it hundreds and hundreds and hundreds of examples because it takes forever. But eventually it will start to have an idea for what a 4 looks like, and then zeros, and then all the way up to 9. So this is really an intense kind of algorithm that was made for this type of process, but it doesn't really take any computational power. This is something that if we had come up with in the 80s or even the 90s, we definitely could have started using it back then. One of the other examples I was talking about was cloud computation. And a cloud is really just a centralized database of information that people can access externally. That way they don't have to have that information specifically on their own devices, freeing up space and making it so it's less of a tax on your own computer. The way we use these cloud systems can be kind of intense today, but we've had systems going back to the 70s talking about how to use cloud systems. So again, it's not really about the technology you're using, and it's not really about the resources you have available at your disposal. It's about having an idea, like going to the moon, and figuring out how you're going to make that idea work with the technology you have available.